Hello, thanks for tuning in. My name is Josh Colston. I'm an epidemiologist, and in this explainer video, I'm going to be talking about anthropometric indicators of nutritional status, how they are calculated, how they are interpreted or what they mean, and how they can provide us with a very informative, sensitive, robust, and easily calculated measurement of the health of a particular population. So to get things rolling, I wanted to show you this picture. Seems to have been taken in India. It's from a BBC article. And all I want you to notice about these children in this photograph are just how normal they look. They are adorable, goofy kids, smiling and joking around. They seem very at ease and relaxed in each other's company. And really, there's nothing about them or their size that would distinguish them from any group of kids that you might find in a school anywhere in the world. Until we reveal the top part of the picture, and here someone has drawn this line a couple of inches above the heads of these children. And this represents the average height that a child should measure if they've been fed adequately and growing up in an environment that is well suited to their growth and development through the early years of their life. And as we can see, these children in this photograph are falling somewhat short of this expectation. There's one particularly petite girl in the middle there who's quite a bit shorter than what we would expect if of a let's say a normal population. And all that is to say that there is variation in the size that people are at different ages within and between populations, and there are norms and expectations around the size that children will reach as they grow up from birth and through adolescence into adulthood. So now I'm going to talk about the causes and consequences of childhood undernutrition. So undernutrition is the phenomenon that might prevent a child from reaching that optimal size. And it has several causes, most notably and perhaps most obviously the inadequate intake or absorption of energy, protein and micronutrients in food and diet. Now that seems quite intuitive, but perhaps you haven't heard it expressed in quite that way. As a child grows up, they have particular windows of need for their body to develop, needing particular nutrients at particular times. And because their parents aren't always aware of what particular nutrients or components of food they need at any given time, it's important for them to have a very varied diet in those important years, early years of their life. Repeated infections are a common cause of childhood undernutrition. If you imagine a child that is getting sick from being infected many times, well, that illness can reduce their appetite, so they don't have a desire to eat 3 meals a day, whatever it may be, and they end up consuming less food than they would otherwise if they were not getting sick. Impaired gut function, so there are many bugs that infect our intestines, our guts. They cause diarrheal disease, which causes water and food to get expelled, but also it repeatedly damages the lining of the intestine. And if you think of what that lining is for, it's for absorbing nutrients from the food as it moves through the digestive tract. And if that lining is damaged, then it's not able to absorb the nutrients needed to the degree that it should. Now, what about the consequences of undernutrition during childhood? Well, they are manifold. Growth faltering being the most notable and the one illustrated in that picture before. So that is a child not reaching the size that they should, or the optimal size for their age at any given time in their early life. Impaired cognitive development. So if you think of those nutrients being absorbed by the digestive system, those are needed for building and developing the organs of the body. And of course, the brain is an organ of the body. It needs particular nutrients at particular times as it's developing. And if it doesn't get them it can leave a child permanently impaired and unable to perform the cognitive tasks needed for daily life to the required extent. It makes a child increasingly susceptible to further infections. So here we see a vicious cycle of infection and undernutrition, with both causing the other. And there's increasing evidence that children who are chronically undernourished during the early years of their life are more likely to develop chronic or metabolic diseases when they eventually reach adulthood. And all this amounts to diminished life prospects. And these negative effects of childhood undernutrition on life prospects through all these various mechanisms is unfortunately irreversible. Once a child deviates from the path of desired growth, it's virtually impossible to get them back on it. And that's why we want to identify these deviations as early as we can when they occur, to nip it in the bud. Now, anthropometry is the measurement of the human body. And thankfully, we have some very handy, easily used instruments for measuring and diagnosing undernutrition in children. You can see this photograph. Here we have some survey enumerators who have come to this little girl's house, and they've asked her parents if they'd mind if they measured her, and so they're in the middle of measuring her height. She looks very happy, and indeed children really like this. They love to see how big they're getting. They love to compare themselves to their peers, and parents like to see it as well. They like to know how well their child is growing, whether they're meeting certain growth milestones. So this is a very handy and robust, as I said, way to measure the size of a human being. Just take measures and scales. Now I'm going to take a slight detour into statistics and talk about some concepts that you may remember from any class that you've taken in that subject in the past. Quite basic concepts: normal distributions and their standard deviations. So if you remember, a normal distribution in statistics shows the number of individuals who have particular values for a variable across all the range of values that variable might take. And if that variable is normally distributed, you have a population mean in the middle, and then the values tapering either side in a nice symmetrical way, tapering off to these tails at the far extremes on either side. Now, we can see from this figure, which is a histogram of children's weight. This is all children who were 2 years of age, and it's taken from a nationally representative survey conducted in India. So many thousands of children's weights are plotted on this figure. And we can see that weight of a child at a particular age, 2 years old in this case, exhibits this normal distribution shape. And the same applies to height at a given age. And now standard deviations are a related concept. They are just a measurement of the dispersion of a normally distributed variable. So normal distributions can be flat and sort of squashed down, like the one on the top, and they take a standard the value for their standard deviation, that Greek letter there that you can see with the arrows. That value will be larger, a higher value, than for the distribution at the bottom, which is more squashed, more narrowly distributed, which would take a smaller value for its standard deviation. And now I want to introduce the concept of child growth standards. Now, these are data and statistics made available by the WHO, endorsed by the WHO, and internationally recognized. They describe the distribution of height and weight at every child, at every age from 0 to 59 months, and for both sexes. and they describe growth under optimal conditions. For example, the conditions of the child being fed in the appropriate way at each age. So breastfed from birth to over the first months of life, and then gradually introducing solid foods and eventually weaning them off breastfeeding altogether. And these growth standards are based on real data from real children in 6 geographically diverse countries. So 6 cohorts of children who were recruited by this WHO team of epidemiologists, followed very intensively over those first 59 months of their lives following their birth, and measured at each point with averages and standard deviations recorded. And so these growth standards can be plotted in a growth chart like the one we see on the right here. Along the x-axis we have the child's age in months, and on the y-axis, well, the lower part is the weight and the upper part is the length. We say length rather than height because this is for children up to 2 years of age, and not all of them can stand up. So they would, so the investigators would lay them out on a surface and measure their length as opposed to their height. And we see that increasing with age, and we can imagine that at every age point in this in the life of a child, there is a normal distribution of their length, of their height, of their weight that is distributed around a mean and takes on standard deviations as well. Now, I'm going to introduce the concept of a z-score or a z-score. This is a measurement of the difference between a particular value that an individual has for a variable and the population mean of that variable. And these scores are expressed in units of standard deviation. So they vary around a 0. They can be lower than 0 or higher than a 0. And if we take a normal distribution of height at a given age, I'll show you some examples of how we might assign a z-score to an individual based around that distribution. So if a person happens to be the exact average height of a population at that age, they would have a z-score of 0. If a person's height was exactly 1 standard deviation above the mean of their population, they would have a z-score of 1. If they were half a standard deviation shorter than the average for the population, they would take a z-score of negative 0.5, minus 0.5. If they're further towards the tail end, towards the lower extreme of the distribution, they have they are 2.2 standard deviations below the population mean, then they have a z-score of negative 2.2, minus 2.2. So with these concepts, normal distributions, standard deviations, and z-scores, we can start to construct indicators of childhood undernutrition for individuals and the populations of which they're a part. Let's say we know the age of a child, we have measured their height, and we have weighed them on scales. We can start to construct 3 indicators of their nutritional status. If they have a low height, below a negative z-score for their age, we can say they have a low height for age z-score or a low length for age z-score, depending on how their height or length was measured. This is an indicator of chronic undernutrition, so more prolonged lack of adequacy in their nutritional intake. And in its extreme form, this is known as stunting. So when I was a child, I was always told, oh, when you grow up, please don't smoke. It will stunt your growth. So the idea being if you start smoking when you're not fully grown, you won't reach your full growth potential. That's how I remember stunting. And now we also know their weight and their height. So if we can take the z-score of their height given their weight, and if that is low, if it's below the mean. We can say that they have a low weight for height z-score, which is an indicator of acute undernutrition. That means a more sudden shock to their nutritional intake, like from a famine or a very hard, difficult period economically for their families, say. And this is known as wasting. So also as a child, I was told, eat your entire meal, don't leave anything or you'll waste away. Meaning that I would get so thin that I'd gradually dissolve into nothing. That's how I remember this word wasting, which is more to do with weight, whereas stunting is to do with height. And then there's a third. We can take the child's weight relative to the distribution at a given age. And if that is low, their weight for age z-score is low, that is a composite indicator. It's a kind of combination of this chronic and acute components of undernutrition. And we simply call that being underweight. So let's look at the picture worldwide of growth faltering or failure to attain optimal growth. This is summed from 54 studies in various different countries, and it shows a fairly typical picture for a population of children in a low resource setting. We see that their height for age starts very close to zero. That means when they're born, they might be very close to those optimally nourished, that growth standard that we saw earlier, those cohorts from the 6 countries that got all the feeding right and minimal infections. They start out close to that, but very alarmingly, almost immediately following birth, their height for age plummets. They drop down to close to a z-score of -2. So 2 standard deviations below what we would expect if they were in an optimal situation. By about 2 years of age, that's they're around -2, and they basically stay there. They don't recover that growth. They stay undernourished, and they don't make up for it. Weight for length, remember that's the more acute indicator of acute undernutrition, and that hovers around 0 because remember that's short-term shocks to nutrition. So there may be, if we were to look at a higher resolution, we might see some up and down, but that stays close to the growth standard. And of course, weight for age is a composite of the two, so that we can see it falling neatly between the two. And here we have another picture. This is from a particular population, a cohort of 303 infants in Peru, from some of my own research. And we can see that they actually start from a worse place than the global picture. They start almost 1 standard deviation, a z-score of -1, below the mean. And they exhibit this plummeting at a even more rapid rate towards a z-score of -2. And they never really retain, they never really catch up and retain that growth. So this is alarming, and it's very noticeable, the effects of undernutrition in populations of children. But now we have a problem, because if we're saying that any child who has a negative z-score is stunted or wasted, depending on the measurement, then by definition we're saying that half of the population in an optimal environment for nutrition, half of that standard population is meets the definition for being undernourished. That seems like we need a more stringent definition of that. We don't want to say that about half the population. So often we'll take certain thresholds. So we might say that anyone who is 1 or more standard deviations below the growth standard average, i.e. a z-score of -1 or lower, we could say that they are at least mildly stunted or wasted. And then we might take the -2 threshold for being moderate to severely stunted, And then it's not shown on this diagram, but a z-score of -3, so 3 standard deviations below the average for the healthy population, is severe stunting. And that's way off towards the tail end. You really don't get those people. Those are really rare in a healthy population. So if someone has a z-score of 3 or lower, a child, then you know that something's not right. So when we apply these cutoffs, here's what we get. Stunting, or a child being stunted, having chronic undernutrition. Generally, we're talking about them having a LAZ, length for age z-score, also height for age z-score, of -2 or lower. So people often use stunting as a shorthand for moderately to severely stunted. It's such a widely used cutoff that they don't need to say the moderately to severely part. They just say stunting, and most people know what they mean. Wasting, similarly, -2 or lower. Underweight, that's for the weight for age z-score. These are how these 3 indicators of different aspects of undernutrition are defined. So, how does this picture look when we take it for a whole population of a country, a very large country, in this case Nigeria? So here we have a map that's plotted the prevalence, so the proportion of children who are wasted, who have a z-score of a weight for height z-score of -2 or lower, and this is in Nigeria, and it's by state. So each of the 30 or so, however many there are states, is color-coded according to that prevalence. And, well, I don't know a great deal about Nigeria, but one thing I do know is that the northernmost states, or the northern part of the country, tends to be the lower resourced region, lower socioeconomic status of the population there compared to the coastal states of the south. And what we see is that picture very well reflected in the nutritional status of the children. So the children in the north more likely to be wasted, more likely to be suffering from acute malnutrition, presumably as a result of this lack of access to resources. And now these z-scores are such robust and sensitive indicators of general health status that they're often just used as surrogates for the general health status of a child. And that in epidemiological terms, when constructing a hypothesis or investigating a research question, they can be treated either as exposures or as outcomes. So in the example to the left, we have 3 biomarkers, and how here the change in the LAZ score, length for age z-score, is treated as an exposure, and we see how that impacts biomarker concentrations over different lag lengths. Whereas on the other side, on the right, we've got control and stunted individuals, so normally nourished and stunted individuals treated as outcomes and compared to concentrations of biomarkers. So again, often it's such a general indicator of the health status that we would just take that as a surrogate. So in summary, undernutrition in early childhood is common in low resource settings, but preventable through diet and feeding interventions. It has a wide range of serious health consequences, many of which are irreversible and permanent, and do not manifest until adulthood. An easily ascertained outward sign of undernutrition in young children is growth faltering. That means the failure to reach the expected height or weight by the right age. A child's growth, an individual child, or the average growth of a population of children is most meaningfully assessed in comparison with that of a healthy population with optimal diet and feeding. Specifically, height for age or weight for age z-scores, relative to reference standards, can quantify deviations from a healthy growth trajectory, providing sensitive indicators of, respectively, chronic and acute undernutrition. And height for age z-score and weight for height z-scores are often dichotomized at a value of -2, -2, with children below that threshold categorized as, respectively, moderately or severely stunted or wasted. So, thanks again for tuning in, and I hope now you've come away with a better understanding of how undernutrition in populations is measured and assessed.